Every day, we take hundreds of bites of food without a second thought. You chew and you swallow, and you rarely think about the biological machinery required to process that meal until you get an upset stomach. This illustrates the sheer scale of the gastrointestinal tract. If you pulled the entire tract out and stretched it in a straight line, it would measure 30 feet long, about the length of a school bus, coiled tightly beneath your stomach. The objective is highly specific. It breaks down dead matter, extracts the microscopic nutrients, and segregates the leftover toxic waste so it can be safely expelled. This map of the human torso shows the system divided into two factions. The hollow organs of the gastrointestinal tract act as the main pipeline, while the adjacent chemical organs of the biliary tract produce fluids to dissolve the food. Digestion is rarely a passive holding stage. It is an aggressive, highly coordinated disassembly process. Without it, your body would starve, regardless of how much you eat. Curious? The breakdown actually starts before you even taste your food. The moment you see and smell a meal, your salivary glands activate. They release moisture into your mouth to lubricate the food before your teeth begin crushing it. Once chewed, the food moves down your esophagus, a long tube situated right behind your windpipe in the center of your chest. This diagram shows the esophagus in action. Gravity alone doesn't drop the food. Instead, peristalsis uses rhythmic muscular waves to actively force the solid mass downward. If the protective barrier weakens, highly acidic fluid can breach the gate and flow backward, causing acid reflux. The upper digestive tract relies entirely on these strict one-way physical gates. They ensure the corrosive internal mechanisms required to process a meal don't accidentally escape and damage your own tissue. Once past the gate, the food lands in your stomach on the left side of your upper abdomen. This is a harsh environment where powerful acids and enzymes physically and chemically bash the material into a semi-solid sludge. The stomach itself is lined with a thick protective coating to withstand this extreme acidity. When that tough lining is compromised, the acid eats directly into the tissue, creating painful open sores known as stomach ulcers. As the acidic sludge pushes out of the stomach and enters the small intestine, the physical squeezing of the hollow organs is no longer enough to process the material. This schematic details the biliary tract, the liver, pancreas, and gallbladder. Operating as secondary chemical laboratories, these organs inject bile and specialized juices directly into the small intestine, reacting with the semi-solid sludge and completely liquefying it. Your body extracts nutrients through this exact sequence. The raw material must first be physically crushed in the holding tank, followed immediately by chemical liquefaction. Now a fluid, the mixture navigates the 22-foot coiled muscular tube of the small intestine. This is the longest part of your entire gastrointestinal tract, and its primary job is pulling the dissolved nutrients completely out of the liquid mixture and passing them into your body. This vital absorption phase is easily derailed by certain pathological roadblocks, the most notable being celiac disease. Looking at this microscopic view of an intestinal wall, you see what happens when a patient with celiac consumes gluten. The protein triggers an autoimmune response that inflames the lining, creating a physical barrier that blocks necessary nutrients from passing into the bloodstream. Assuming the lining is healthy, the small intestine pulls what it needs. The leftover, nutrient-stripped material is then pushed into the large intestine, your colon, rectum, and anus. The large intestine has one primary mechanical function. It pulls the remaining water out of the liquid waste, compressing the leftovers into solid stool. Timing dictates the outcome of this entire phase. If the waste moves too slowly, the intestine pulls out too much water, resulting in hard, dry constipation. If it moves too quickly, the water isn't absorbed at all, causing diarrhea. A mechanical slowdown, an immune reaction, or an acidic breach at any single stage of this 30-foot pipeline cascades quickly. A localized disruption becomes a systemic failure of the entire digestive sequence. Because this vast network requires so many individual organs to collaborate sequentially, the assembly line is highly vulnerable to external inputs. Take the mechanical necessity of hydration. Drinking adequate amounts of water provides the essential lubricant that keeps solid matter flowing easily through the 30-foot tract, preventing blockages. The system also relies on specific materials to run efficiently. Dietary fiber directly aids the physical processing of food, while probiotics introduce beneficial bacteria into the gut ecosystem to fight off pathogens. Even the pace at which you consume a meal changes the internal mechanics. The practice of mindful eating, deliberately slowing down to chew food thoroughly, reduces the initial size of the matter, significantly easing the physical burden on your stomach and intestines. There is also a direct neurological connection. High psychological stress triggers physical responses in the gut, often resulting in disorders like irritable bowel syndrome, constipation, and diarrhea. By consciously managing your diet, hydration, and stress levels, you act as the manager of this microscopic 30-foot assembly line, dictating the materials and maintenance required to keep it sustain your life.